Thank you to our wonderful MC, Dr. Fahad Firdaus. We are, as he said, the process optimization of hot tub testing, sponsored by Soft Tub Inc. I'm Kyle Penniman, the team leader. This is Jason Piazza, Sam McSweeney, Brajesh Patel, and Madi Termos. Quick background on our company. It was founded by Tom Thornberry. He's the owner and founder. They create very unusual foam hot tubs that work in a variety of situations. Their main focus is that they are light and that they have the ability to be moved in outside or inside depending on the season. So that makes them really popular with people who live in climates that are both cold and hot, so you can enjoy it all year round. They're also located in Nash Road in New Bedford, so it's only about 10 minutes away from here. And I'm going to turn it over to Sam now.
So the main task of our project was to redesign the final testing process for Soft Tub. As Kyle mentioned, they make foam hot tubs. They make them in 3 sizes. There is a 140-gallon, a 220-gallon, and a 300-gallon hot tub. They are color customizable by the customer. So the process is testing for leaks. So they have a testing platform that is 21 feet by 24 feet. And on the platform, they have 2 donor tubs, which are just 2 of the largest tubs that they have that just store water for the testing. Currently, they can test 40 tubs per day, and their goal is for us to come up with a process that will allow them to test 60 tubs per day. Along with increasing the throughput of the process, some of our major parameters were to incorporate a storage tank that would hold at least 900 gallons of water, be able to have a filtration system to keep the water clean, and dispense the water using gravity. The only constraint that we had was that we cannot change the dimensions of the testing platform. This is our project management, how everything's divided among our team members. So one of the main focus points of our project ended up being these time studies to actually verify that our process would increase the throughput. So we had to observe the current process and came up with these 5 steps that they do. So they set up the tub, then they'll fill the tub with water, they'll run the test, so they'll turn the pump on, run the water through the unit, turn the lights on, run the filter, the jets, then they'll drain the tub, and then they'll dry it and check it for leaks, and then they'll ship it to the customer. So we observed 3 hot tubs. One was a 220-gallon and 2 300-gallon hot tubs. And these are the times that we got when we visited the facility. And then we got an average time for each step. And then we inflated the times for the time studies that we conducted to allow for human error and anything that might come up. And Jason is going to talk about our designs.
So as Kyle stated before, Soft Tub is currently located in New Bedford on Nash Road, roughly 10 minutes from the campus itself. They currently operate out of a 3rd-story old mill. So our first design implemented 2 tanks, a 600 and 700-gallon tank that Soft Tub already had in storage. Those can be seen. We mounted those to the 3rd floor, and our design was to plumb PVC piping from the 3rd floor down to the testing platform that they currently use. This would allow us to test 3 tubs simultaneously, and then we would be using a high-head pump to pump the water back up into the storage tanks. Unfortunately, we realized very quickly that that design was not going to work when we ran into issues of finding a high enough pump with a high enough flow rate to return the water back to the storage tank. We also realized that with water staying stagnant inside the PVC piping on weekends or overnight could also occur algae buildup, which we wanted to stay away from, and we wanted to not worry about them having to clean the PVC piping. And the biggest problem with that was it was not modular, so they wouldn't be able to move this setup. If they decided to rearrange their testing setup, they wanted to move different platforms to other sides of their factory, and it just wasn't going to be able to be implemented. So that brings us to our second design, which we went down to a single storage tub. We returned everything back to the 1st floor and implemented just the storage tank on the testing platform. The testing platform was 21 by 24, as Samantha said earlier. This design implemented bi-directional pumps that would flow back and forth between the tubs and go back to the storage tank to store water. We also incorporated a filtration system, that way the water could be cleaned while it was sitting overnight, during the day while they were doing testing, or over the weekend so that the water wasn't staying stagnant. We also ran into a few more issues with that. Having bi-directional pumps, we couldn't find something that was better than the flow rate they were currently using for their submersible pumps, so we weren't getting an adequate test result, and it wouldn't have been beneficial to actually do that. So now I'm going to turn it over to Brajesh, who's going to talk about our third design and our final design.
Now, since you all know that our previous design didn't work well with the scope of the project, we had to move with another design, just like any other engineering problem. So we decided we sat together and decided that why don't we elevate the tank by having an aluminum stand on which we can mount the main storage tank. So you can see here that the storage tank is elevated at a certain height, and you can see the stand over here from the top view. So what's going to happen is that the water will be cavity feed from the main storage tank down into the first two tubs represented here. And then when those two tubs are tested, water will be transferred from these two tubs into the two at the far corner using the submersible pumps. And then at the end of the day, when all the tubs are done, water will be transferred back into the main storage tank using the submersible pumps. So we brought that idea to the client, and then we found problems, which were two of them actually. So one problem was that to manufacture the stand alone would cost us more than $2,000, which was way over the budget, which was only $1,000. And the other reason was not continuing with the design was that the workers that work around the platform might face some problems in the future, just in case there is a big leak or any catastrophic accident happens, which leads to our final design. So you can see that it's pretty much similar than what we had previously. The only difference between this design and the previous design is that we got rid of the stand here, as you can see. So in this one, what's going to happen is that at the beginning of the day, we are going to implement a stock ticket system, like how many tubs you are going to test per day. So we can start with a 140-gallon tub at the beginning of the day, have these two white tubs filled from the main storage tank using gravity feed. And when these two tubs are tested, attach the submersible pumps and transfer that water into the two of the orange ones. And then these white ones will be ready to be rolled out, get dried, and ready for shipping. And then new tubs will be introduced, and this process repeats itself throughout the end of the day. And similarly, like the previous design, at the end, this whole water that was drained out will be moved back into the main storage tank to get ready for the next day. So as you all know, we all engineers are fond of numbers. So here are some flow rate calculations that we did. At the beginning of the day, we have, so the backline here, it shows the height to which the first tub would be filled. So you can see we get an average flow rate of almost 100 gallons per minute. And after that, we don't have to worry about the decreasing flow rate since we are using the submersible pumps to transfer the back and forth. Hence, and then also, I would like to point out that this was an essential part of the project since this was a baseline for the time studies which we did, which Jason is going to talk about in the next slide.
So as Brajesh stated, as engineers, validation is key in choosing a final design. So in order to validate our design for our stock ticket setup and everything like that, making sure our pumps would work, making sure our storage tank could hold enough water, we calculated over a dozen time studies. These time studies were basically broken up, and the most important ones were included in this slide. As you can see on the left-hand side, if I can direct your attention, this was testing a single-size tub throughout the day. So the red is 140, the yellow is a 220-gallon, and the orange is a 300-gallon. We did these testings with both a single operator, which is what they currently use, and a dual operator to see if it was more beneficial to hire someone else. So as you can see, for a single operator, we have 116, 88, 68 tubs, and for dual operator, we have 150, 120, and 105 tubs. The next testing that we did that was most important was we broke up soft tubs 7.5-hour workday into sections of thirds in order to say, okay, so for the first third of the day, they're going to test all 140s. For the second third of the day, they're going to test 220s, and so on and so forth. With those calculations, We received 87 for a single operator, which is the amount of tubs a single operator could get finished in a day, which doubled currently what they're doing now and surpassed the 60 that Soft Tub was looking for. And if they decided to implement another operator, we have a 120 throughput throughout the day. We also understand that because Soft Tub does a lot of custom work, Soft Tub has more than 10 different skins you can add to your size of your tub. We realize that a stock ticket may not be the easiest implementation into their current design. So we did a worst case scenario where if you're starting with a 300 gallon, let's say, and then you're swapping to a 140 and then back to a 300, you're going to have to use the submersible pumps to pump the excess water back into the storage tank, and you're also going to use that storage tank to have to use gravity feed if you're running low on water. With those tests, we have a single operator doing 55, which is 5 less than what they were looking for, but the dual operator was capable of doing 88. We also have some console that Kyle's going to explain next on the next page for the 21 by 24 platform.
So to determine whether or not the platform would be able to withstand the added weight of the water that we would be putting on it with our storage tank, what we did was we looked at how the platform was constructed, and it has a very similar construction to the deck you would have on your house, where you have vertical boards across the bottom and horizontal boards across the top that you walk on. So what we did is we took one of those boards, which happened to be a 2x6 pressure treated, and we put those dimensions into COMSOL, and we took 1/3 and also the entire weight of the water tank and put that on top to check the maximum stress that we would see in that piece. With looking at the 1/3, you can see that there was a 244 kPa load, and with the entire weight there's a 731 kPa load, both of which are severely below the maximum stress that you can have in that material before it deforms too much or breaks. So that confirms that we would be able to apply that load to the testing platform without any supports or any extra modification. To validate these results, we compared them to hand calculations that we did for the same situations, and they varied by about 1.2 to 1.3%, confirming that the simulations that we did were correct and valid. To verify our time studies, we weren't actually able to implement the design at the current moment because Soft Tub is a seasonal business, as they're in the business of hot tubs, and most people don't want to purchase and install hot tubs in the winter, so now that it's getting warm out, their production is increasing and they don't have the time to fully implement our design and to have downtime on their production line. So they will be looking to implement our design later on this year once production starts to slow down. Now I'm going to pass it over to Manny to explain our goals. Sorry, cost breakdown first. We were given $1,000 initially. We looked at how much a tank would cost as we knew that we needed a new tank since the ones that they had were both too small to test both 200 gallons at the same time. So with needing to purchase a new tank, as you can see, it's $685. With shipping on top of that, which is not included in that price, it's going to be almost our full $1,000 budget. So we went to our clients and we spoke to them, and they permitted us to go forward with a design as if we were given more money, and with just keeping prices in line so not go overboard with the parts that we were ordering, and we were able to come up with a budget of around $2,400 of projected expenses. Now I'll be turning it over to Minnie.
Thanks, Kyle. As you can see, this is a bullet point of the goals that our design have met. So we were able to increase the testing throughput to over 60 tubs per day on most of our scenarios, and we've implemented the storage tank on the platform as specified in the scope of the project, and we've implemented a filtration system to keep the water clean. And as well, we are able to test 2 tubs simultaneously as a minimum for now. Some of the design improvements that we can implement on our current final design is we can implement this as the client feels. So we can increase the capacity of the storage tank. That way it'll allow us to test more tubs simultaneously, 3 or 4. And we can automate the valve. That way we will prevent overspilling and wasting of water and wasting of time. And we can purchase higher flow rate pumps. That way it'll speed the overall process of our system. So some of the lessons learned in our project is that simple is always better, and we need to stay away from over-engineering our design and always go back and review the scope of our project so we don't wander away from our initial goals. So recommended future actions is to actually purchase the parts as soon as possible to prevent long lead times, because that was one of the major parts why our design couldn't be built. The tanks took too long to order and to get delivered. And since SoftUp is a seasonal business, so we would recommend you guys to assemble our design in the engineering facility and have it built and make sure that it works as it should, and train workers over there. That way the transition, when you want to implement it on the actual craft, will be smoother, and the employees will have more experience on the new design. This is the only reference that we've used. Now I'm going to hand it to Kyle.
Before we take any questions, we'd like to give a special thanks to SoftUp for sponsoring this product, or for this project, as well as our wonderful advisor, Dr. Shanka Bowman, for being countless help to us throughout this entire project.